Hello, my name is Vanessa Lee, and this is my project for the Science and Engineering Fair of Houston. This year, I did a study on the effects of sleep deprivation on the resting heart rate during sleep. To start off with some general background information, sleep is a process that is vital to the human body. The National Center for Biotechnology recommends 7 to 8 hours of sleep for young adults. However, the reality is that some people do not meet this full requirement. Sleep deprivation, or the state of your body when you do not rest long enough, has many negative physical and mental consequences, which include weight gain, depression, lack of judgment, loss of memory, blurred vision, and loss of sensory receptions. The most notable consequence is the increased risk of heart problems due to long-term sleep deprivation, as described by the Heart Foundation. The focus of my study will be to examine the effects of sleep deprivation on the sleeping heart rate. In my literary review, I found that the Center for Disease Control has positively linked sleep deprivation with hypertension or high blood pressure. However, I am not currently aware of any study that has linked the effects of heart rate and sleep deprivation. For my hypothesis in this experiment, if the number of hours of sleep a person receives is decreased, then their average resting heart rate during sleep will increase because the body does not have sufficient time to completely go through the sleep cycle. Since this is a statistical analysis study, my null hypothesis is the amount of sleep has no effect on the resting heart rate. My alternative hypothesis is if the amount of sleep is decreased, then the resting heart rate will also increase. My independent variable is the amount of sleep that participants receive, and my dependent variable is the sleeping heart rate in beats per minute. My controls will be the first two trials, which are 7 to 8 hours of sleep. For my experimental methodology, the resources and materials I will require are 10 participants, heart rate measuring devices such as Fitbit or Apple Watch, a timer, laboratory notebook, and computer device. For my procedure, first, each participant will wear a heart rate measuring device before going to sleep. Then they will set a timer for how long they are supposed to sleep and wake up at designated times. The participants will then note their resting heart rate while they were asleep, as recorded by the heart rate measuring device. And finally, participants will repeat the steps 1 through 4 for each trial with a differing sleep time. There are a total of 6 trials, which are 8, 7, 6, 5, 4, and 3 hours of sleep. I had to note the participants and their safeties during this study. In our experiment, we enlisted the help of 10 volunteers who owned Fitbit and Apple Watch. These volunteers' age ranges from 16 to 20, classifying our study group as young adults. As our study involves sleep, some potential safety hazards faced during the study is the induced effects of sleep deprivation. Participants were encouraged not to conduct trials on nights back to back. I have included the graphs of the data I have compiled. The first graph shows the average sleeping heart rate with marginal error, while the second graph shows the sleeping heart rate of 3 to 5 hours of sleep versus 7 to 8 hours of sleep among the participants. For my data analysis, after obtaining all the data values, I split them into 2 groups. 3 to 5 hours of sleep is the one group of sleep deprivation, and the 7 to 8 hours of sleep is control variable, showing that they had sufficient sleep. Below are key statistical findings in the bullet points. The mean for 3 to 5 hours of sleep is 54.83 beats per minute, while the mean for 7 to 8 hours of sleep is 53.50 beats per minute. Because a t-statistic of 0.991 is less than the critical value of 1.833 at the alpha level of 0.05 in the 9th degree of freedom, we fail to reject the null hypothesis. The data is not statistically significant to prove that sleep deprivation has an effect on the sleeping heart rate. Also looking at the marginal error graph, since the bars overlap, this means that there is not enough data to prove that there is a significant difference between the 2 groups. So in conclusion, my experimental study has failed to reject the null hypothesis. Even though the mean beats per minute of 7 to 8 hours of sleep was lower than that of 3 to 5 hours of sleep, the obtained data was not statistically significant enough to prove a relationship between sleep deprivation and increased sleeping heart rate. My study did face some limitations. The accuracy of the heart measuring devices are questionable, since there are many factors that can affect these readings, such as restless sleep or the device not being worn properly. There may be confounding variables at play that affect each participant's sleeping heart rate, like stress level or medication. Overall, this study could have been more precise if these problems were addressed. And I have my citations listed to the side. Thank you for listening to my presentation.